Welcome back for part 2 of lesson 6.1 in college algebra. We are talking about quartic functions today, so here's an basic form of a polynomial function with an x to the fourth in it. If it has an x to the fourth, it's quadratic. It can or does not have to have all the rest of these terms here. The picture you see down below here is the basic quartic function y equals x to the fourth with no other numbers involved. You can see that it looks a lot like a parabola, but it's got a little flatter bottom here, and the sides are going up faster, because when you take a number to the fourth power, it's going to get big. Alright, so what we're going to look at is the end behavior of quartics and other polynomial functions, but when you see a quartic, it will have both ends going up or both ends going down, and that will depend on that leading coefficient, which is the value of the number right here in front of x to the fourth. So if it's positive, they're going up, and if it's negative, they're going down, just like a parabola. But they're not always all shaped like a parabola. If they have those other terms, they can have more curves, variations in the curve, but the ends will still both be up or both be down. Now, to generalize this to all polynomials, if the graph of a function of degree n has at most n minus 1 turning points. So earlier in the lesson with the cubics, we said if it's degree 3, it has at most 2 turning points. So with quartics, degree 4, they're going to have at most 3 turning points. So those local extrema, the max and the mins that you're looking for, there will be at most 3 for a quartic function. The graph of a polynomial function of degree n has at most n intercepts. So if this is degree 4, we're looking for up to 4, but it could have less. The end behavior, if it's odd, that's an important point right there. If this is odd, they will have one end up and one end down. And if it's even, both ends are up or both ends are down. Let's take a look at a couple specific examples. So first of all, we've got this shape here. Now don't try to guess too much what it is, what the equation is before you answer the parts A through D. So part A, how many x-intercepts does this have? Well, it crosses the graph twice. How many turning points? It goes down and then up. That is only one turning point. Is the leading coefficient going to be positive or negative? Well, both ends are opening up, so it's positive. Is the degree of the polynomial odd or even? Both ends are going in the same direction. That makes it even. So this is a positive, even function. The last question can be a little bit tricky. The minimum possible degree, not what you look at and what you think you see here, because to me this looks like it's probably an x to the fourth, but based on this information, we have 2 x-intercepts, 1 turning point, and we know it's even. It's got to be at least a parabola, a quadratic, degree 2. That minimum has got to be degree 2. Probably not, it's probably degree 4. But all we can say the minimum possible degree is 2. So be careful on that question. Here's a new graph. The number of x-intercepts that we see, 1, 2, 3. The number of turning points. It goes from up to down, that's 1, down to up, that's 2, and up to down, that's 3 turning points. The leading coefficient, because it's opening down, is negative, and they're both going down, so it's even. So this is a negative even. And it can't be degree 2 because we have 3 x-intercepts. So the next even number that would work for this information that we have looked at is degree 4. So this one has to be at least degree 4. It's possible higher, but probably is degree 4. Alright, next one. How many x-intercepts do you see this time? Just 1. Whoops. There's just one place where it crosses the x-axis right there. Turning points, it's always going down. Never turned around and went back up, so there are none. Now for odd functions, you can tell if the leading coefficient is positive or negative based on, I think of it like slope. So when you think about a line, if you start up high and you end down low, that's like downhill. So that would be negative. If the graph is increasing, that's positive. Alright, it must be odd because the ends are going in opposite directions here. So this is a negative odd function. And the minimum degree it could be is 3. because it's not a straight line. If it was a straight line, it would be 1. Alright, next one, x-intercepts. 1, 2, 3 places it crosses. Turning points. Up, down is 1, 2. 2 turning points. And the leading coefficient is, this looks like uphill, so that would be positive. Both ends are opposite directions, so it's odd. So this is positive and odd, and we have at least 3 x-intercepts, so it's got to be 3 or higher. Alright, now for the application problem. This is the data from 2000 projected into 2015 for the U.S. unemployment rate, with the number of x equal to the number of years after 2000. Good thing they didn't include 2020 because that has drastically changed this year. Alright, we've got this function here. It is a quartic. If you have your graphing calculator, you're going to want to put this in your y equals and get a graph of that. They're telling us part A, graph the function. Make your x values from 0 to 15 because that will give us the years indicated up here. The y values, you'll just have to graph it and see what that looks like. So go ahead and do that now. Pause the video. This is the graph you'll get. And you may or may not need to change your y max. It looks like we would fit it just in the screen if you kept it at 10. So that's part A. Part B is asking us to find the max and min after 2002 and before 2015. So pretty much the max and the min, but not over here. So if I just asked you for the minimum, it would be right here at year 0, which is year 2000. But they said after 2002, so they're telling you to look only to the right of this point. So a maximum, well, the graph, it's kind of hard to tell. You might want to zoom in, but it goes up a little bit right here. There's a tiny bit of a max, and then it goes down just a little bit, and then back up and down. So this is obviously not the maximum of the graph because it's over here. So what you would want to do is your second, calculate the max and go left and right and hit enter. And that's going to give you your maximum, and then this point over here, which would be a little bit tricky to find. You can't like start over here and go over here because you would get a minimum over here. So make sure you stay kind of close in and do your left, second calculate the minimum, and go left and right kind of nearby that point. Now when they ask you for the max and the min, they're probably looking for the, they want the maximum and the year, so they want the whole point. And this is the unemployment rate. So 3.92, almost 2004. We've got an employment rate of 5.25, and in 2012, during 2012, 9.49 was a maximum. 2012 there was a economic recession a little bit. Last question, is it likely that this model can be used to estimate the unemployment rate for very long after 2015? Well, it starts diving. It's probably not going to go down to 0, and then we can't have a 0 unemployment rate forever. We obviously know that that's not true. So it's not very good, probably very much at all after 2015. Probably going to come down here and start to recover, and then who knows, because 2020 it's taking a dive again. Alright, that ends Lesson 6.1. Your homework is posted on Google Classroom, and you can also ask me questions on Google Classroom, and if I get the same question a bunch, I'll try to do videos or something to help you out. Have a good day.